Welcome back, Grade 6, to Nelson Math, Chapter 7, Section 6, Investigating Properties of Quadrilaterals. Quadrilaterals, quad for four, and laterals for sides. So quadrilateral, four sides. Here we have a number of different quadrilaterals, and we are going to look at two different properties, whether their diagonals are equal and whether their diagonals meet at 90 degrees. So let's start with a parallelogram. The diagonal is this line that goes from this corner to this corner and this corner to this corner. If we measured them, we would see that they are not equal. So the answer to that is no. Do the diagonals meet at 90 degrees? With the protractor, we would also say the answer is no. I'll just center these here. That's better. Let's look at a rectangle now, right here. Here's our rectangle. Are the diagonals equal length? The answer is yes. Do the diagonals meet at 90 degrees? And clearly they do not. Let's look at a square. Are the diagonals the same length? Yes, they are. Do the diagonals meet at 90 degrees? Absolutely they do. That's one way that you can tell if in fact it is a square. If the diagonals and if those diagonals meet at 90 degrees. So that's one way of being able to tell that. Our next one, we're going to look at a rhombus. So our rhombus, which is right here, the rhombus, you can see from here that the diagonals do meet at 90 degrees, so we can say yes. However, the diagonals are not of equal length. This diagonal is longer than this diagonal, so the answer here would be no. For an irregular quadrilateral, you could see that they don't meet at 90 degrees and they're not the same length, so that's no for both. Here is a kite. For a kite, they meet at 90 degrees, but they do not have the same length. So that would be a no. And here we have a trapezoid. The trapezoid, they do have the same lengths. So this line and this line are the same, but they do not meet at 90 degrees. So a question like this lends itself very well to sorting all of these shapes into a Venn diagram. So we would be able to label this Venn diagram regarding what they have. So I've created here a simple Venn diagram, two circles that overlap. This is the middle overlap, and I'm going to label them. So labeling them, this one I can call equal diagonal length, and I'm going to use the short form because we're short on space. So equal diagonals, and I'm going to call this one diagonals meet at 90 degrees. Like that. See if I can space it a bit better. All right, so we have our two names or labels for our Venn diagrams. So in here would be the ones that say yes for both. So we're going to put here square, and I'm going to highlight it like this. So it's yes for both. Let's make it bold so I don't use it twice. So square goes in the middle. I'll make a little text box like that. So square goes in here. And are there any more that have yes on both sides? And the answer is no, they don't. So only my square has equal diagonals and diagonals that meet at 90 degrees. Let's look for now for any of the quadrilaterals that have equal diagonals but don't meet at 90 degrees. So equal diagonals, the rectangle meets at equal diagonals but not at 90 degrees. So I'll highlight this so that I don't use it again. And I'll call this rectangle. Like that. And let's look for any more that have equal diagonals, but they meet equal diagonals, but not at 90 degrees. There's the trapezoid, so I can do the trapezoid right here. So I have labeled these. So square has equal diagonals and diagonals that meet at 90 degrees. And rectangle and trapezoids have equal diagonals, but the diagonals do not meet at 90 degrees. So I can highlight that one. So I don't choose that one again. Let's look for quadrilaterals where the diagonals meet at 90 degrees, but they're unequal diagonals. So we could start from up here, and the rhombus has diagonals that meet at 90 degrees, but they're unequal diagonals. So let's highlight this one. And I'll call this rhombus. Like that. So our rhombus has been taken care of. Are there any more that the diagonals meet at 90 degrees, but the diagonals are unequal? So 90 degrees and unequal, that's right here. Kite. So we can do kite in this side. Like that. So we can highlight kite so we don't use that one again. Are there any more that the diagonals meet at 90 degrees, but they meet at 90 degrees, but they don't have equal diagonals? And the answer is no, as both the parallelogram and irregular quadrilateral both say no. So we can add this, outside of that, we can call it the parallelogram. And the irregular quadrilateral. Both. And here is our Venn diagram where we have sorted all seven of these. So 2, 4, 6, 7. They've all been sorted into their properties. And we can do this with properties of quadrilaterals or triangles or any other polygons as well. Thanks, everyone. Have a good day.